Hi everyone, welcome to our tutorial. For today's video, we will discuss about reactive system and thermodynamics. So let's start. Reactive system problem number 2. 1 kilomole of octane C8H18 is burned with air that contains 20 kilomole of oxygen or O2. Assuming the products contain only CO2, carbon dioxide, H2O or water, O2 oxygen and N2 nitrogen, determine the mole number of each gas in the product and the air-fuel ratio for this combustion process. So, in this problem, we are asked to identify the mole number of each gas and also the air-fuel ratio for this combustion process. So, let's start. First, we will have chemical equation. So, for chemical equation, for C8H18, it is known as octane plus 20, which is our kilomole of oxygen. So 20 quantity of oxygen plus 3.76 N2 nitrogen. So goes to X CO2 for carbon dioxide plus Y H2O for water plus Z for oxygen plus W for nitrogen. So this explains that where the terms in the parentheses represents the composition of dry air that contains 1 kilomoles of oxygen, and X, Y, Z, and W, this one, X, Y, Z, and W, they represents the unknown mole numbers of the gases. So these unknowns are determined by applying the mass balance to each of the elements, that is, by requiring that the total mass of or mole number of each element in the reactants be equal to that in the products. So we have carbon here, H for hydrogen, O for oxygen, and N2 is for our nitrogen. So for C, we have 8 equals 8. So for our H, we have 18 equals 2Y. So for our O, we have 20 times 2 equals 2X plus Y plus 2Z. And for our nitrogen, we have 20 multiplied to 3.76 equals W. So let us solve for it. X equals 8 equals 8. X, so we have X equals 8. So 18 equals 2Y. So we have Y equals 9. So for our O, 20 multiplied to 2 equals 2X plus Y plus 2Z. So we will now have the value of our Z, which is 7.5. So let's solve for the value of our W. So 20 multiplied to 3.76, we will have W, which is 75.2. So we have now the respective values of each element, which is X for 8, Y for 9, Z for 7.5, and W for 75.2. So let us proceed now in substituting yields. So as we can see here, we will be substituting the X by 8, which is here, for Y, which is 9, and for Z, which is 7.5, and for W, which is 75.2. So as we can see in this part, we replace each element values to its corresponding numbers. So octane plus 20, oxygen plus 3.76, N2 nitrogen goes to 8 carbon dioxide plus 9H2 for water plus 7.50 of oxygen, or 7.5 of oxygen plus 75.2 nitrogen. So note that the coefficient in the balance equation above represents the number of moles of oxygen, so not the number of moles of air. So let's bear it in our mind. The latter is obtained by adding 20 multiplied to 3.76. So we have 75.2 moles of nitrogen to the 20 moles of oxygen, giving a total of 95.2 moles of air. So the fuel or the air fuel ratio or AF is determined by taking the ratio of the mass to the air and the mass of the fuel. So let us proceed in finding our AF or air fuel. So the formula that we will be using in finding the air fuel is equals to AF equals M of air over M of fuel equals Nm of air over Nm of C plus Nm of H2. So by substituting the values, we have AF equals to, for M, 20 times 4.76 kilomoles and 29 multiplied to 29 kilograms per mole over 8 kilomole multiplied to 12 kilograms per kilomole plus 9 kilomole multiplied to 2 kilograms per mole. Okay, by putting it in our calculator, we can have now the value of our air fuel, which is 24.2 kilograms of air per kilogram of fuel. So we have now the value of our air fuel and the value of our gas. So this is the end of our tutorial. Thank you for listening. God bless everyone.